Hello there, and welcome back to the Quiet Sleep Science. I'm so glad you've drifted your way here tonight. Maybe your day has been full and heavy, or maybe your thoughts are still spinning, looking for a place to rest. Either way, you can let all of that go now. Your body can soften, your breath can deepen, and your mind can relax. Because tonight, we aren't staying close to home. We are slipping into the dark, into the most mysterious objects the universe has ever known. Tonight, we are falling gently toward black holes. These are not just stars. They are not just places. They are boundaries in space-time, where the rules we thought we understood begin to bend, to stretch, and to break. They are quiet, invisible giants that curve the very fabric of reality. They are destruction and creation intertwined, endings that concede beginnings, shadows that reveal light. For as long as we've looked to the skies, black holes have stirred our curiosity. And tonight, as you rest, they will guide us into sleep. Let's begin with what a black hole is. Imagine a star, massive and luminous, burning for millions of years. At its heart, nuclear fusion pushes outward, balancing the immense gravity pulling inward. For a time, this balance holds, but nothing lasts forever. When the fuel is spent, the outward push fades. Gravity wins. The star collapses inward, tighter and tighter, until even light can no longer escape its pull. What's left is not just a remnant, but a place where space itself has folded in on itself. A singularity wrapped in an invisible horizon. From the outside, you see nothing but darkness. But that darkness is not empty. It is the most intense concentration of gravity the universe allows. Astronomers call the boundary the event horizon. Cross it, and there is no coming back. Not for matter, not for energy, not even for light itself. To us, it looks like a black sphere, perfectly opaque against the cosmos. But around that edge, extraordinary things happen. Matter falling in glows with radiation, gas swirls in luminous disks, and space-time itself bends so severely that light curves and stretches into arcs. The edge of a black hole is not silent. It is a place of intense activity, a border between what we can see and what we can never know. And yet, for all their fearsome reputation, black holes are not cosmic vacuum cleaners, swallowing everything in reach. Unless you stray too close, you could orbit one safely, just as the Earth orbits the Sun. If our Sun was suddenly replaced by a black hole of the same mass, our orbit would not change. The Earth would still drift in its path, lit only by the stars beyond. Black holes pull with gravity, but no more than any other object of equal mass. Their danger lies in proximity, not in distance. It is when you approach the horizon that the story changes. Time itself behaves strangely near a black hole. To someone watching from afar, a falling object appears to slow as it nears the horizon, stretched into eternity. To the object itself, though, time passes normally. It crosses the horizon without pause, continuing toward the singularity. From the outside, it seems frozen. From the inside, it is unstoppable. Black holes remind us that time is not fixed. It is relative, woven together with space in ways we only glimpse when gravity is this strong. At the very center lies the singularity, a point of infinite density, where all the mass has collapsed into a space so small our physics cannot describe it. Our equations break, our understanding fails. It is the ultimate mystery, a place where the known laws of the universe go silent. Whether the singularity is truly a point or something else we cannot yet imagine remains one of the deepest questions in science. Black holes are not just objects. They are questions written into the night sky. But we don't need to cross the horizon to witness their influence. Some black holes announce themselves by their hunger. Gas and dust spiral in, forming what astronomers call an accretion disk. Friction heats the material until it glows with X-rays, shining brighter than entire galaxies. In these moments, black holes become paradoxical, invisible at their center, yet radiant at their edges. Some even launch jets of particles, narrow streams that fire outward for thousands of light-years. These jets, born from magnetic fields at the brink of the horizon, are among the most powerful phenomena in the universe. Out of darkness comes brilliance. Out of silence comes thunder. And so, as you drift tonight, know that you are resting in a universe where such things exist. Places where time bends, where stars collapse, and where light itself can be trapped. Black holes may seem terrifying, but in truth, they are part of the same cosmos that gave you breath. The atoms in your body have felt their pull. The photons in your eyes may have bent around their edges. You are connected to their mystery, even here, even now, lying quietly under the soft turning of the earth. Black holes are not rare. The universe is filled with them. Some are as small as a single city, yet heavier than the sun. Others weigh millions, even billions of times more, anchoring the centers of galaxies. These are the supermassive black holes, the giants around which whole star systems revolve. At the heart of our own Milky Way lies Sagittarius A Chi, a black hole over 4 million times the mass of the sun. From Earth it is hidden behind thick curtains of dust, invisible to our eyes. But astronomers have traced the orbits of nearby stars whipping around an unseen point, moving so quickly that only something with tremendous gravity could explain it. They circle an emptiness that is not empty, a shadow more massive than anything nearby. It wasn't until recently that we glimpsed one directly. In 2019, the Event Horizon Telescope revealed the first image of a black hole's silhouette in the galaxy M87, a glowing orange ring, blurred and yet unmistakable, surrounding a round dark center. It was not the singularity itself, but the shadow it casts, carved by light bent around the horizon. For the first time, humanity saw not a simulation, not a guess, but the outline of the unseeable. And in that ring of fire, the universe whispered confirmation. Black holes are real. The physics around them is so extreme that even the words we use can feel fragile. Take spaghettification, a word that sounds playful, yet describes something merciless. If you fall feet first toward a black hole, the difference in gravity between your feet and your head stretches you, pulling you longer and thinner until you resemble a strand of pasta. For small black holes, this tidal force would tear you apart long before you reach the horizon. For supermassive black holes, the gradient is gentler. You could cross the event horizon without immediate harm, unaware that your fate was sealed. You would not see the singularity approaching. You would simply move toward it, and the universe outside would move further and further away. But as alien as they seem, black holes are also engines of creation. They help regulate the growth of galaxies, controlling how stars form. When a black hole feeds, the jets and radiation it releases can heat and scatter gas clouds, preventing new stars from forming too quickly. Without this balance, galaxies might burn out their fuel in a frenzy of creation, leaving only darkness behind. In this way, black holes act as cosmic regulators, destructive yet life-giving, silent conductors of galactic evolution. Not all black holes are born equal. Stellar black holes form from collapsing stars, but primordial black holes may have formed in the earliest moments after the Big Bang. Tiny seeds of gravity scattered across the newborn cosmos. Some may be no larger than an atom, yet with the mass of a mountain, others may drift invisibly, never seen, never confirmed. They are hypothetical, yes, but possible. If they exist, they could explain mysteries we still wrestle with, like the elusive dark matter that shapes galaxies. And then there are intermediate black holes. Not stellar-sized, not supermassive, but in between. Harder to find, harder to prove, but suspected to dwell in clusters and dwarf galaxies. These middling giants may be the missing link, showing us how the smallest grow into the largest. Perhaps the universe builds in steps, black holes merging and feeding, until they carve out the titans at galactic centers. Perhaps every supermassive black hole began as something far smaller, growing over eons, into the giants we see today. Hawking radiation offers another strange twist. According to Stephen Hawking, black holes are not perfectly black. They can slowly leak energy, as virtual particles at the horizon split, with one falling in and the other escaping. Over immense spans of time, this process could cause black holes to evaporate, shrinking, fading, and finally vanishing in a last faint burst. For stellar black holes, the timescale is far longer than the current age of the universe. For tiny primordial ones, it might already be happening. If so, the cosmos may carry faint whispers of their death cries in the background radiation. Even the darkest objects may not last forever. And yet, paradoxes remain. Information, the arrangement of particles, the history of states, seems to vanish when matter falls into a black hole. Quantum theory says information cannot be destroyed. General relativity says it disappears. This is the black hole information paradox, one of the greatest puzzles in physics. Does information escape in subtle correlations with Hawking radiation? Is it stored on the event horizon, written like holograms on a cosmic surface? Or is there something deeper, something we still do not understand, hidden in the folds of space-time? Black holes may hold the key to uniting quantum mechanics and gravity, the two great theories of modern physics that remain stubbornly separate. As you drift tonight, imagine the quiet persistence of these objects, some born in stellar explosions, others ancient as the universe itself, invisible yet shaping galaxies, silent yet whispering paradoxes. They remind us that the cosmos is not finished teaching us, that mystery still lives in the dark, that not everything needs to be known in order to be meaningful. You are lying under a night sky where black holes hum unseen, their gravity curving the paths of stars, and you are part of that story. Your atoms forged in suns that may one day collapse, your light traveling through a universe sculpted by shadows. If you could stand at the edge of a black hole and look out, the universe itself would appear distorted. Light from distant stars would bend around the horizon, circling it in strange arcs, forming what's called an Einstein ring. To you, the cosmos would seem to wrap itself into curves and loops, as if the night sky were folding in on itself. Colors would stretch, frequencies would shift, and time outside would accelerate. The universe beyond would appear to rush ahead, centuries flashing in moments, as your own clock ticked steadily forward. It is a reminder that perspective is not fixed, that time itself can be relative, shaped by the depth of gravity's well. And yet, from a distance, black holes are invisible. Unless they are feeding, unless they are surrounded by gas or a companion star, they vanish against the night. Astronomers find them by watching how other things move, how stars orbit unseen centers, how gas heats and flickers, how X-rays shine from regions where no visible source exists. Like shadows detected by the light they block, black holes reveal themselves through their influence, not their presence. In a way, they are cosmic detectives, hidden, but leaving trails in everything around them. Some are found in binary systems, paired with normal stars. The star orbits an unseen partner, its light wobbling with the pull of gravity. Sometimes gas streams from the star into the black hole, forming an accretion disk that shines with X-rays detectable from Earth. These systems tell us not only that black holes exist, but that they are part of stellar families, entwined with other suns, sharing their fates. A star's life may end in collapse, but it may still dance with a companion, even as an unseen horizon pulls it close. Collisions between black holes create some of the most powerful events in the universe. When two orbit each other, they spiral closer, their motion stirring ripples in the fabric of space-time itself. These ripples are gravitational waves, traveling outward at the speed of light, stretching and compressing space in faint, delicate pulses. For billions of years, they traveled unseen, until in 2015, scientists detected them for the first time with LIGO. The signal came from two black holes, colliding over 1 billion light-years away. In that instant, 3 times the mass of the Sun was converted into pure gravitational energy, ringing across the cosmos, and Earth trembled with it, though only slightly, less than the width of a proton. Yet even that tiny signal confirmed a century-old prediction of Einstein, and it gave us a new way of listening to the universe. Now, gravitational wave observatories are catching more and more collisions, black holes merging, neutron stars spiraling together, cosmic dances that end in quiet unification. Each wave is like a note in the universe's hidden music, a sound not of air but of space-time itself. To rest beneath the stars is to lie in the middle of this music, washed in waves we cannot feel, yet which move through us constantly. Even in sleep, the universe hums. At the centers of galaxies, supermassive black holes are not quiet passengers. They are active engines shaping their surroundings. In quasars, black holes feed so intensely that their accretion disks outshine the galaxy itself. Light and radiation pour across space, brighter than trillions of stars. Some quasars shine from billions of light-years away, meaning we see them as they were when the universe was young. That such power exists in the distant past tells us that black holes grew rapidly, gathering mass faster than we once thought possible. They are not just relics, they are architects, carving the early structure of galaxies, fueling the cosmic web we see today. Even in their quiet states, black holes remain connected to their galaxies. They influence star formation, regulate gas flows, and anchor motion. Remove them, and the galaxy's story would unfold differently. They are like hidden keystones, unseen but holding structure together. You live in a galaxy where such a keystone lies at the center, quietly spinning, quietly pulling, while stars, planets, and life itself move in its shadow. And yet, despite all we know, black holes remain among the most mysterious things we've discovered. They push physics to its limits. They ask questions we cannot yet answer. What happens beyond the singularity? Is there a bridge to another universe? A wormhole hidden within? Do black holes destroy information, or do they preserve it in ways we cannot yet understand? Each possibility feels like science fiction, but each arises from real equations, real paradoxes, real mysteries. Black holes sit at the edge of knowledge, silent and yet insistent. They are nature's way of reminding us that we have not finished learning. And so, as you close your eyes, imagine these objects drifting across the universe, invisible, yet radiant with meaning, heavy, yet patient, silent, yet full of story. To rest tonight is to share in the same cosmos they inhabit, to breathe under the same stars that orbit their invisible horizons. You are not falling into one, but you are falling into sleep. And in that fall, you share something with the universe itself, a quiet surrender to gravity, a gentle drift into darkness, where time feels slower, softer, endless. The birth of a black hole begins with fire. A star many times heavier than our sun exhausts its fuel, its core collapsing in on itself. The outer layers explode outward in a supernova, scattering heavy elements across the galaxy. Iron, gold, oxygen, the building blocks of life. What remains at the center is a remnant too heavy for atoms to support. Neutrons themselves, crushed beyond their limit, give way. Gravity takes over fully, and a black hole is born. From death comes something stranger than life, a shadow that bends the rules of reality. Not every massive star ends this way. Some collapse into neutron stars, dense spheres, the size of a city, spinning fast, sending out beams of radiation like cosmic lighthouses. Others collapse fully, vanishing behind an event horizon. The universe does not waste. Every collapse enriches the cosmos with new material. Every remnant changes the balance of its surroundings. Black holes are not isolated freaks of nature. They are woven into the cycle of matter and energy, part of the great recycling of stars. Consider the life of our own sun. It is not massive enough to form a black hole. Billions of years from now, it will swell into a red giant, shed its outer layers, and leave behind a white dwarf, a cooling ember that will fade slowly over trillions of years. Black holes belong to stars far more massive, titans, whose fates are sealed by their own size. And so, when you see a star burning brightly in the night, remember that its future depends on its weight. Some will fade gently, others will collapse into shadows. Once formed, black holes can grow. They feed on gas clouds, stars that stray too close. Even other black holes, a stellar mass black hole can merge with others, stepping upward toward larger and larger scales. Over billions of years, these mergers may help build the supermassive giants at galactic centers. The Milky Way's own black hole, Sagittarius AA, did not begin its life as a giant. It grew, patiently, from smaller seeds. Every black hole is a record of growth, a history of encounters written not in light, but in mass. And yet, for all their appetite, black holes also lose. Hawking radiation, faint and slow, gnaws at them over immense timescales. A stellar black hole may last for unimaginable ages, but eventually, even it will fade. The universe is not eternal in any of its forms. Stars die, planets crumble, even black holes dissolve. If time stretches long enough, there may come an age when no stars shine, no galaxies glow, and only black holes remain before they, too, evaporate into darkness. It is called the black hole era, a distant chapter of cosmic history where gravity's shadows are the last beacons. Think of the scale. Right now in the universe we see there may be hundreds of millions of black holes in our galaxy alone. Across the cosmos, trillions upon trillions, each one invisible, yet curving the paths of stars, influencing the shape of galaxies, stirring the balance of matter. And though they seem like endpoints, they are also gateways of curiosity. To study them is to push at the boundaries of physics, to ask what happens when the universe folds in on itself. There is poetry in their paradox. They are places of silence, yet they roar with jets of light. They are regions where nothing escapes, yet they give birth to radiation. They are singularities of collapse, yet they may hold clues to the beginning of time itself. When you listen to a black hole, you are listening to both an ending and a beginning. To drift toward one is to step outside of what we know into a realm where language falters and imagination stretches. Astronomers dream of using black holes as laboratories, to drop instruments near the horizon, to watch how light curves, to test the limits of relativity. Already, satellites measure the ripples of space-time from collisions. Telescopes capture the glowing disks of feeding giants. Each piece of evidence deepens the mystery rather than erasing it. Black holes are not only cosmic objects, they are questions given form. As you drift deeper into sleep, think of the black hole not as something fearful, but as something serene. A horizon where noise ends, a place where time itself slows into quiet. The universe is not simple, but it is patient. And black holes remind us that even in endings, there can be calm. Tonight you are not collapsing into one, but you are letting go, letting yourself sink into rest, as gently as starlight bending around an unseen edge. Imagine drifting near a black hole, carried close but not too close. You would feel no sudden pull, no violent tug. Instead, you would orbit as if around any other massive body, circling quietly, your path steady and smooth. From that orbit, though, the view would be unlike anything else. The black hole would not look like a star. It would be a circle of darkness, perfectly black, surrounded by a halo of distorted light. Stars behind it would bend and smear, stretched into arcs around the shadow. The universe itself would seem to warp, as though space were made of glass and you were looking through its thickest curve. This is gravitational lensing, nature's way of showing us the invisible. The closer you drift, the more extreme the distortions become. The star behind the black hole might appear in two places at once, its light bent into twin images. Rings of light would shimmer, delicate halos formed by photons looping again and again around the horizon before escaping. In some simulations, the accretion disk itself appears doubled, its underside curved upward into view by the bending of space-time. It is an illusion born of gravity, a spectacle that no human eye has yet seen directly, but one we can model and imagine and dream into being. And what of sound? Black holes themselves are silent. Sound requires air or matter to vibrate, but the disks of gas that feed them can roar with radiation, pulsing and flickering as they spiral inward. These fluctuations can be translated into frequencies, signals that resemble sound. In this way, black holes do hum, in tones too low for us to hear, in rhythms too slow for us to grasp. Astronomers have even mapped vibrations in the hot gas around them, finding notes billions of times deeper than the range of human ears. They are like cosmic drums, beating in silence, their rhythm carried not through air but through light. Some galaxies host active black holes that shape everything around them. Their jets pierce through intergalactic space, carrying matter thousands of light-years outward. These jets, though born from darkness, shine with energy across the electromagnetic spectrum. Radio waves, X-rays, gamma rays, they can ignite star formation in nearby regions, or quench it by blowing gas away. Galaxies are not simply collections of stars. They are ecosystems. And at their centers, black holes act as regulators, sometimes nourishing, sometimes starving, always influencing the balance. Even now, in the quiet Milky Way, Sagittarius A flickers faintly. Most of the time it slumbers, feeding lightly on small clouds of gas. But sometimes, astronomers see bright flares of X-rays, as though the giant at our center stirs, stretches, and then falls back into rest. Long ago, it may have burned far brighter, a quasar lighting the galaxy's core. Its calm today is not permanent. In time, new clouds may fall inward, and the heart of our home could blaze again. Galaxies breathe through their black holes, inhaling and exhaling across epochs. But black holes do not only exist in far-off centers, they wander too. A black hole can drift quietly through the galaxy, invisible, undetectable except by the subtle tug it exerts. Some may be remnants of stars that lived and died billions of years ago. A few may pass close to planetary systems, stirring their orbits, bending their paths. We live in a galaxy where silent wanderers may drift unseen, black holes not tied to any one star, not shining, not flaring, only moving in darkness. To sleep beneath this sky is to rest in a universe full of hidden travelers. And then there are questions we cannot answer, not yet. Do black holes truly hide wormholes, bridges to other universes or other regions of our own? Could something that falls through ever emerge elsewhere, transformed, carried across space-time? Most physicists doubt it, but the mathematics leaves small windows open, gaps through which speculation slips. Even if wormholes are not real, black holes remind us that space-time is not rigid. It bends, it flexes, it surprises. Perhaps the universe holds pathways we have not yet imagined. Perhaps the future will reveal them. As you drift further into rest, you can imagine the quiet persistence of these objects. They do not hurry, they do not waver, they wait in the dark, shaping galaxies, bending light, holding mysteries. In their stillness, there is a kind of calm. To think of black holes is not only to think of destruction, but of patience. They remind us that the universe moves slowly, that change can take billions of years, that even in collapse there is time. Tonight, as you close your eyes, you can let your thoughts collapse too, not into fear, but into silence, into a stillness as deep as a horizon, where no light escapes. Not all black holes live alone. Some exist in pairs, bound together by gravity, circling one another in spirals that last for millions of years. As they orbit, they shed energy through gravitational waves, drawing closer, tighter, until at last they merge. The final moments are a crescendo. The horizons touch, their masses combine, and a single larger black hole is born. The collision releases more energy than all the stars in the observable universe shining at once, but not in light. In gravity, ripples expand outward, carrying the news across the cosmos. If you close your eyes tonight, you can imagine those ripples still traveling, passing silently through you, through Earth, through every atom, too faint to feel, yet vast enough to shake space-time itself. Some black holes may orbit not just one partner, but entire clusters. In dense regions like globular clusters or galactic centers, encounters can fling stars outward, capture new companions, and create tangled dances of gravity. Sometimes neutron stars spiral into black holes, their collisions enriching the cosmos with heavy elements like gold and platinum. These cataclysms, though rare, forge the metals that later become part of planets, part of bodies, part of lives. To think of a wedding ring or a heartbeat of iron and blood is to trace a lineage back to mergers in darkness, to collisions that ended in silence, but left echoes in matter itself. And yet, for all their violence, black holes can also be subtle. Some are so small, so quiet, that they pass unnoticed. Astronomers suspect there are millions in our galaxy alone, unseen because they are not feeding, not flaring, not surrounded by glowing disks. They are dark, drifting, and patient. Perhaps some lie closer to Earth than we imagine, invisible neighbors we cannot yet detect. The sky above us may be sprinkled not only with stars but with silent horizons. Our understanding of black holes comes not only from theory, but from experiment. Telescopes trace the X-ray flares of feeding systems. Gravitational wave detectors listen for collisions. Computers model the flow of gas and the bending of light. And yet, the core mystery remains untouched. We cannot see beyond the horizon. We cannot probe the singularity. It is a veil that no observation can pierce. And perhaps, in that veil lies the key to uniting the great theories of physics, general relativity, which describes gravity and space-time, and quantum mechanics, which describes particles and energy. Black holes sit at the border, demanding a bridge between worlds. Some scientists dream of a theory of quantum gravity, where space-time is not smooth but made of tiny discrete structures, a fabric woven from information. In this view, the horizon of a black hole may not be a featureless surface, but a place where information clings, stored like code on a cosmic screen. Some propose that black holes are holograms, projecting information outward in subtle ways. Others imagine that the singularity never forms, replaced by something new, a quantum star, a loop of space-time, a remnant we do not yet understand. Each idea stretches imagination, but all are born from the puzzle black holes present. And there are stranger ideas still, that black holes could birth new universes, that each collapse might pinch off space-time, creating a bubble that expands into its own cosmos, with its own laws of physics, unreachable to us but real nonetheless. If so, then our universe itself might have been born inside a black hole in another universe, part of an endless chain of creation, hidden in collapse. We cannot know, not yet. But the thought itself is a reminder. Endings can be beginnings, and darkness can hold seeds of light. Even now, as you listen, new black holes are being born, stars collapsing in distant galaxies, collisions releasing waves, quiet wanderers drifting unseen. The universe is not still. It is alive with hidden motion. And though we may never see a singularity with our own eyes, we can feel its influence in the stars around us, in the atoms of our bodies, in the light that curves through space. Black holes may be far away, but their story is part of ours. And so tonight, as you rest, you are not falling into one, but you are letting yourself be carried by the same laws that guide them. Gravity holds you to Earth. Time moves gently around you. The universe continues its slow, patient dance, with black holes as silent partners. Sleep is its own kind of horizon, a threshold you cross, leaving one world behind and drifting into another. You are safe to fall. You are safe to rest. The darkness that holds you is not an end, but a place of renewal. Some black holes may be older than galaxies themselves. Astronomers suspect that the earliest moments after the Big Bang might have created primordial black holes, tiny horizons formed from dense regions of the newborn universe. If they exist, some could still wander today, scattered through space like invisible fossils of creation. They would not be born of stars, but of pure density, collapsed before galaxies, before light, before stars had even formed. We do not yet know if they are real, but if they are, they could be countless, hidden across the cosmos. They might even account for some of the dark matter, the unseen mass that binds galaxies together. Imagine a universe sprinkled with invisible pinpricks of collapse, ancient shadows drifting since the dawn of time. But not all black holes are tiny. Some are so massive that their size defies imagination. In the galaxy Holm 15A, astronomers discovered a black hole weighing more than 40 billion suns. Its horizon would stretch beyond the orbit of Neptune. If placed in our solar system, these giants sit at the centers of clusters, consuming and merging, growing into incomprehensible scales. They remind us that the universe does not limit itself to what feels reasonable. It builds extremes, from the smallest particles to the largest horizons, and asks us to expand our imagination. Even our own Sagittarius A is modest compared to others. 4 million suns in mass, yes, but small beside the monsters of the cosmos. And yet, it is ours. The stars near it orbit in strange, rapid paths, tracing invisible loops that prove its presence. One star called S2 completes a full orbit in just 16 years, whipping around the center at a fraction of light speed. To watch its path is to watch gravity at its most intense, stars moving like comets around nothing at all. It is like watching a dance around emptiness, and yet that emptiness holds everything in place. Black holes also connect us to the idea of entropy, the measure of disorder in the universe. In physics, black holes are said to have entropy proportional to the area of their horizon. The larger the horizon, the more entropy, the more information it hides. This discovery reshaped our understanding of thermodynamics and linked black holes to deep questions about time itself. Why does time move forward? Why does disorder increase? Black holes may hold clues, their surfaces carrying the imprints of all they consume, their very existence tied to the arrow of time. And then there is Hawking's insight that black holes radiate. It was a shocking idea, because it suggested black holes are not eternal prisons. They leak. Slowly, invisibly, but inexorably. They lose energy. For stellar black holes, this process is far too slow to matter. But for tiny black holes, it could be rapid. Some might have already evaporated since the beginning of the universe, vanishing in faint bursts of energy. And in the far future, when stars are gone and galaxies are dark, black holes themselves may fade, leaving only radiation in a silent cosmos, the last fireworks of time. It is a humbling thought that the most powerful objects we know may one day be gone, that even horizons dissolve, that nothing lasts forever, not stars, not galaxies, not even the great shadows that seem eternal. The universe writes in eras, each with its own actors, each with its own endings. And black holes are part of that story, but not its conclusion. Still, in the present, they remain, scattered across the sky, hidden in galaxies, shaping the paths of stars, stirring the structure of the cosmos. They are here now, even if we cannot see them. And that is enough to fill us with wonder. For when you look up at the stars tonight, you are not only seeing light, you are also sensing absence. Hidden among the glowing constellations are places where light ends, where space curves too deeply to escape. You live in a universe with shadows vast enough to swallow suns, and yet delicate enough to whisper paradoxes into the equations of physics. And as you breathe now, slowly, calmly, you are resting in that same universe. It is not threatening you. It is not rushing you. It is simply existing, vast and patient, with black holes as silent companions. The night is long, the stars are steady, and you are drifting, like light itself, gently bending into the curve of rest. Some black holes announce themselves not by light but by motion. Astronomers have found stars racing across the galaxy at astonishing speeds, so fast they cannot be bound to the Milky Way. These hypervelocity stars may have once orbited near the central black hole, only to be flung outward when a companion fell in. One star captured, the other cast away, a cosmic slingshot, sending it into intergalactic space. To watch such a star move is to see a silent memory of a black hole's hidden power, written not in light but in velocity. Even when invisible, black holes shape the paths of travelers, scattering stars like sparks from a fire. Sometimes, entire clusters of stars bear the marks of encounters. Streams of light arc across the sky, the remnants of galaxies torn apart by tidal forces, their stars stretched into long ribbons. Black holes, both stellar and supermassive, play a role in these disruptions, pulling stars into new paths, unraveling order into delicate threads. The night sky holds scars, if we know how to look, scars left by gravity itself. In the densest regions, where stars crowd close, collisions are possible, not of stars with black holes, but stars with each other, drawn together by chaotic orbits, stirred by gravity's web. When they collide, they merge, forming luminous blue stragglers, stars that appear younger than their neighbors. In these crowded stellar cities, time can seem out of order, some stars reborn while others fade. Black holes sit quietly nearby, influencing without being seen, their presence woven into the rhythm of stellar lives. And there are echoes we can detect, not with eyes, but with instruments. Radio telescopes capture the whispers of matter spiraling in. X-ray observatories see flares from hot gas at the brink of collapse. Gravitational wave detectors listen to the final beats of merging horizons. Each technology reveals a different layer, a different way of sensing the same invisible giants. To study black holes is to build senses beyond our own, to hear with gravity, to see with particles, to imagine with mathematics. The images we do have, faint and blurred, are triumphs of patience. The Event Horizon Telescope combined signals from observatories across the Earth, turning our planet into one giant eye. In doing so, it revealed the shadow of M87's black hole, a ring of fire around darkness. Later it revealed the shadow of Sagittarius A, our own galactic center. These images are not photographs in the ordinary sense. They are reconstructions from radio waves gathered across continents, stitched together by algorithm. And yet, when you look at them, you see something real. The outline of a horizon, the mark of a place where light itself cannot escape. Humanity for the first time gazed at the unseeable and found it there, glowing at the edge of that beyond the science. There is something deeply human in our fascination with black holes. They embody mystery. They retent the unknown. For centuries, people looked up at the night sky and wondered what lay in the darkness. Now we know that some of that darkness is literal, regions where light ends, To contemplate a black hole is to confront the edge of knowledge. And perhaps that is why they feel both terrifying and beautiful. They remind us that not everything must be illuminated to be meaningful, that there is value in the shadows, in the unanswered question. And they remind us too of scale. A black hole can be no bigger than a city, yet heavier than the sun. It can be larger than our solar system, yet invisible. It can outshine galaxies, and yet be silent at its core. They bend our sense of proportion, stretching imagination to match their gravity. In their presence, we are small, but in our ability to imagine them, to map them, to describe their paradoxes, we are vast. As you rest now, think of the way your own body follows gravity. Your breath, rising and falling, your weight held softly by the earth, your heart moving at its own pace. You are part of the same laws that govern black holes. You are not apart from them. You are within the same fabric of space-time. The universe is not distant. It flows through you, around you, within you. To let go into sleep is to surrender to that same fabric, to follow its quiet curve into rest. In the heart of a black hole, our understanding collapses. We call it a singularity, a point where density becomes infinite, where the equations of general relativity break down. But perhaps singularity is just a placeholder for something deeper, something we do not yet comprehend. It may be that the singularity is not a point at all, but a region where space-time is folded into patterns beyond our current vision. Strings, loops, quantum structures, whispers of theories yet to be proven. When we speak of singularities, we are not describing reality so much as admitting the limits of what we know. Black holes are not only objects in the universe, they are mirrors showing us the edges of our knowledge. Some imagine black holes not as prisons, but as gateways. In theory, a rotating black hole could connect to another region of space-time through what is called a wormhole. Step in, and perhaps you emerge somewhere else. Another galaxy, another universe, another era. Most physicists believe such wormholes, if they exist, would be unstable, collapsing before anything could pass through. And yet, the mathematics does not forbid them entirely. So we wonder, so we imagine. Black holes tempt us not only with what is, but with what might be. Even without wormholes, black holes already connect us to distant places. The jets they launch can stretch for thousands of light years, carrying matter far into intergalactic space. These jets seed the universe with energy, with particles, with structure. In their quiet way, black holes stitch galaxies into the cosmic web. They are not isolated, but communal. Not only endings, but contributors to something larger. The universe grows not in spite of them, but because of them. And black holes may hold the secret to reconciling two great truths of physics. Relativity, which tells us how space-time bends. Quantum mechanics, which tells us how particles behave. For the most part, these two worlds stay separate, each precise in its domain, but inside a black hole, both must apply. And they clash. To resolve that clash would be to glimpse a deeper theory, one that unites the fabric of space with the dance of particles. Black holes are not merely mysteries, they are opportunity. They are natural laboratories for the next revolution in science. Yet even as we pursue the mathematics, there is something poetic about their silence. A black hole does not proclaim itself. It does not shimmer with color or hymn with sound, unless matter falls inward. Most of the time, it waits quietly in darkness, invisible, undetectable, yet certain there is humility in their stillness. To know they exist is to know that the universe holds secrets patiently, without need for spectacle. They remind us that grandeur can be quiet, that power can be still. Think of the long future of the cosmos. Stars will burn out, galaxies will fade, but black holes will remain, drifting through a cold, dark universe. In that distant age, they may be the last actors, the final structures, the last places where gravity holds sway. And even then, they will evaporate, their energy bleeding away, their horizons shrinking. The final fireworks will not be bursts of stars, but faint sighs of fading black holes. The universe will end, not with fire, but with silence. And within that silence, perhaps there will still be traces of what once was. The light of stars, the warmth of suns, the quiet of horizons. But that future is unimaginably far away. For now, the universe is still young. Stars burn, galaxies glow, black holes grow and merge. We live in a vibrant chapter where the cosmos is alive with motion and light. Black holes are not yet relics, they are participants. And as you lie here breathing softly, the universe continues. Collisions ripple through space-time. Jets fire across galaxies. Stars collapse and horizons form. And all of it happens without noise, without disruption, without haste. The universe is not in a hurry, and neither are you. So let yourself drift. The darkness around you is not threatening. It is patient, like a horizon, waiting quietly at the edge of light. Sleep comes not as an end, but as a passage, like drifting across a boundary, where thought dissolves into dream. You are safe in that passage, carried gently by the same laws that shape black holes, the same gravity that holds galaxies, the same time that curves across the universe. Tonight you are part of that story, one heartbeat among stars, one breath in a cosmos vast and alive. Black holes are not only cosmic curiosities, they are teachers. By observing them, by measuring their effects, we refine our understanding of the universe. Every star that orbits Sagittarius AI, every ripple detected by LIGO, every flicker of X-rays from an accretion disk adds a line to the story of physics. They confirm Einstein's predictions, and sometimes they challenge them. They reveal that the universe is not only stranger than we imagined, but stranger than we can imagine. And in that strangeness lies possibility, new theories, new discoveries, new ways of seeing. Consider how much we have already learned. A century ago, black holes were only equations, strange solutions to Einstein's relativity that few believed could exist. Today, we have photographed their shadows, listened to their collisions, traced their influence across billions of light years. What was once speculation is now evidence. And yet, even with all this progress, the deepest questions remain unanswered. Black holes show us that science is not an endpoint, but a journey, and that mystery is not the enemy of knowledge, but its companion. We often imagine black holes as devourers, but they also inspire. Their paradoxes force us to think differently, to ask questions about time, information, and existence itself. They connect physics with philosophy, observation with imagination. What does it mean for information to vanish? What happens beyond a horizon we cannot cross? What is the shape of reality when space itself can fold? These are not only scientific puzzles, they are invitations to wonder. And in wonder, there is calm. For black holes remind us that the universe is vast, and that our worries, our struggles, are small by comparison. The deadlines, the noise, the weight of a single day, all of it shrinks beside a horizon billions of kilometers wide. And yet, that does not make our lives meaningless. It makes them precious. Against the backdrop of eternity, every breath is rare, every moment fragile, every kindness luminous. Black holes remind us of scale, and in doing so, remind us of value. The cosmos is not chaotic without order. Even black holes, with their darkness and collapse, obey precise laws. Their horizons have temperature, entropy, surface area. Their growth and decay follow rules we can write, equations we can solve. Beneath the mystery, there is structure. The universe is not random. It is intricate, balanced, patient. To rest tonight is to fall into that same order. To know that even in uncertainty, there is rhythm. Even in darkness, there is pattern, and black holes are part of the cycle. Stars are born, they burn, they die, they collapse. Their deaths enrich galaxies with elements that form new stars, new planets, new lives. Black holes in their silence mark the continuation of that cycle. They recycle matter, they sculpt galaxies, they regulate growth. They are not interruptions to the story of the universe. They are chapters within it. Imagine, for a moment, drifting above one, a quiet horizon beneath you, the stars curving strangely around its edge. You would see not chaos, but order, not violence, but balance. The black hole does not chase, does not demand. It simply exists, curving space, shaping time, a silent presence at the heart of gravity. In that stillness, there is a lesson that existence need not be loud to matter. That presence itself is power. So let yourself rest in that thought that you too are part of this balance, that your life, your breath, your heart follow the same laws that guide stars and horizons. The universe is vast, but it is also continuous, connected. Black holes may seem remote, but they are woven into the same fabric you are. Their gravity is your gravity. Their time is your time. And as you sink into sleep, you are not drifting away from them, but with them, carried in the same current of space-time. Far in the future, long after our sun has faded and the galaxies have dimmed, black holes will remain. They will drift through the silence, the last great structures of a dying cosmos. This age, when stars no longer form, when galaxies grow faint, will be ruled by horizons. Stellar remnants will fall into them. Whole systems will be consumed, and in that distant night, the universe will belong to black holes. Astronomers call it the black hole era, a time so far away it is almost impossible to imagine, when all light is memory and gravity holds the last word. But even black holes cannot last forever. Hawking radiation ensures that slowly, patiently, they evaporate. For giants, the size of Sagittarius AA, this process would take a timescale beyond anything human minds can truly grasp. Trillions upon trillions of years. For the largest, perhaps longer than the age of the universe squared. And yet, given enough time, their horizons shrink, their mass decreases, and eventually, they vanish in a final burst of energy. The universe, once full of stars and galaxies, will dissolve into a thin sea of particles, faint and cold. The last fireworks will not be supernovae, but the fading size of black holes evaporating into nothing. We live in a young cosmos compared to that distant future. Galaxies still collide, stars still form, black holes still grow. It is a lively age, full of motion, full of light. To exist now is to live during the golden era, when the universe is still ablaze with energy. The horizons that one day will dominate are today only part of the story, sharing the stage with stars, nebulae, planets, and life. We are not yet in the age of silence. We are in the age of brilliance, and we are witnesses to it. Still, to imagine the long future is to feel awe. The universe is not built on our timescales. It does not measure in days or years, but in billions, trillions, quadrillions. Black holes remind us of this immensity. They ask us to expand our sense of time, to think beyond the narrow present. They show us that the story of the cosmos is not a brief flash, but an unfolding tapestry, vast and intricate, in which we are one small but luminous thread. And even though they may one day vanish, the role they play endures. Without black holes, galaxies would not be the same. Without galaxies, stars would not cluster. Without stars, planets would not form. And without planets, life, as we know it, would not emerge. Black holes, in their silence, are part of our story. They shaped the galaxies, that shaped the stars, that shaped us. To think of them is to think of origins, as much as of ends. They also remind us that we are explorers of imagination. No human will ever cross an event horizon and return. No eye will ever see a singularity. Yet we reach for them in thought, in mathematics, in models. We step into their shadows with our minds, even when our bodies cannot, and in doing so, we expand what it means to be human. Black holes are not just cosmic objects. They are symbols of curiosity, of courage, of the desire to touch what lies beyond. Tonight, as you breathe softly, let that curiosity quiet into calm. The universe is vast, but you are part of it. The same gravity that bends light around a horizon holds you gently to Earth. The same space-time that curves around black holes cradles you as you sleep. You are not separate from the cosmos. You are an expression of it, a fragment of starlight, a ripple in gravity, a thought shaped from dust. To close your eyes is not to leave the universe, but to drift deeper into it. Time itself begins to blur, near a black hole. Imagine two twins, one drifting safely far from the horizon, the other daring to descend closer. For the twin who stays away, time passes normally. Days, months, years unfold. But for the one who lingers near the horizon, gravity stretches time itself. Minutes for them may become centuries for the other. When the traveler returns, they are younger, while their twin has grown old. This is not fantasy. It is a consequence of relativity, tested in experiments, observed in satellites, measured in the ticking of atomic clocks. Near a black hole, time itself bends like light, elastic, uneven, patient. From our perspective, anything that falls toward a horizon appears to slow. Light from it grows redder, dimmer, stretched to infinity. To us, it never crosses the horizon. It hovers, frozen in time. But for the object itself, nothing unusual happens. It crosses without pause, continuing inward, as though the horizon were only another invisible boundary. Two realities at once, frozen from outside, flowing from within. Black holes remind us that perspective shapes experience, that time is not absolute, that the universe does not keep a single clock. And what would it feel like to hover there? You would see the universe speed up, stars racing through their lives, galaxies colliding, even the expansion of the cosmos unfolding in rapid motion. To linger at the edge of a horizon is to glimpse time on fast forward, while your own heartbeat remains steady. No science fiction can surpass this truth. Black holes are natural time machines, slowing your clock while the cosmos rushes ahead. Astronomers use this to measure gravity itself. Satellites around Earth tick slightly differently than clocks on the surface. GPS systems must correct for it. Near a black hole, the difference grows overwhelming. Every orbiting star that circles Sagittarius A carries with it not just position, but time stretched by gravity. By measuring their paths, by recording their pulses, we glimpse the way space-time bends under weight. Black holes are not only shadows, they are instruments, showing us how time itself responds to gravity. But there is also philosophy hidden in this science. If time can slow, if moments can stretch, then eternity itself may be relative. Perhaps there is no single now that all of us share. Perhaps the universe is a vast quilt of overlapping perspectives, each stitched by gravity and motion. Black holes remind us that our experience is not the whole of reality, that other perspectives exist, even if we cannot see them. In that reminder is humility, and perhaps comfort. The universe is stranger than we imagine, and we are part of it, not separate from it. As you drift tonight, think of that twin waiting at the edge, watching the stars move faster, centuries flowing like minutes. Think of how their heartbeat remains calm, steady, while the universe hurries on around them. And then think of yourself lying quietly, your own heartbeat slow, your own moments stretching. In a way, you too are near a horizon, the horizon of sleep, Beyond it lies another perspective, another rhythm, another measure of time. You need only let yourself drift. Matter falling into a black hole follows a journey both violent and serene. From far away, it may begin as a drifting gas cloud, thin and delicate, spread across light years. Slowly gravity gathers it inward, pulling strands of hydrogen, helium, and dust. As the cloud approaches, it flattens into a disk spiraling ever closer, heating as it spins. Friction within the disk ignites it into brilliance, radiation pouring outward. Paradox, the darkest object in the universe surrounded by some of the brightest light it can produce. To watch this process from afar is to witness a ballet of destruction. Streams of matter form arcs, whipping inward at incredible speeds. Temperatures rise to millions of degrees. X-rays and gamma rays flicker, evidence of gas caught in a spiral of no return. Yet for the gas itself, the fall is not fire, but inevitability. It circles faster, tighter, until at last it crosses the horizon and vanishes from view. From the outside, its journey never ends. From the inside, it ends too quickly to measure. Stars too can fall victim to this dance. A star that drifts too close may be torn apart by tidal forces, stretched into filaments of gas. Astronomers call this a tidal disruption event. For days, weeks, months, the black hole flares with the star's remains, a final echo of light before silence. Some of the star's matter escapes, flung outward by the encounter. Some circles for a time in a glowing disk, but much is consumed, absorbed into the horizon, gone forever. These flares, brief on cosmic scales, are signposts across the night, proof that black holes feed, that they are not just dormant shadows, but active participants in their galaxies. Even planets are not safe. In theory, a planet could orbit a black hole just as it orbits a star, stable and enduring. But if the orbit decays, if the path curves too near, the planet too would fall inward, its crust torn, its oceans vaporized, its core stretched and scattered. We have not yet seen such an event, but the equations predict it. Black holes are equal in their appetite. They do not distinguish between dust and stars, between planets and light. All that matters is gravity, and gravity is patient. And yet, the story of matter falling into a black hole is not only about loss, it is also about transformation. The energy released during accretion can trigger star formation in surrounding regions. Jets launched outward can shape entire galaxies. A single star consumed can send ripples of energy across thousands of light years, stirring gas clouds, influencing new generations of stars. What falls inward is not erased from the universe's memory. Its fall leaves traces in radiation, in structure, in the ongoing evolution of galaxies. Nothing in the cosmos is wasted. For us, watching from a quiet planet far away, these processes are reminders that the universe is dynamic, not still. That creation and destruction are intertwined. That even the fall of a star can light up the sky, however briefly. To imagine matter spiraling inward is to imagine not only an ending, but a contribution to jets, to light, to new beginnings elsewhere. And as you drift into sleep, you can think of yourself as part of that same cycle. You inhale and exhale. You rest and rise. You end one day and begin another. The universe works in spirals, in collapses, in renewals. You are not outside of it. You are within it, following your own path, your own rhythm, your own gentle fall into rest. Black holes may seem like solitary creatures, but they are architects of galaxies. At the centers of most large galaxies, supermassive black holes sit quietly or blaze with power, shaping everything around them. They are not just passengers in the cosmic story. They are conductors, setting the rhythm of star formation, sculpting the growth of spiral arms, even influencing the fate of their host galaxies across billions of years. When a black hole feeds, the energy released can outshine all the stars in its galaxy. Radiation bursts outward, heating surrounding gas, pushing it away, preventing it from collapsing into new stars. Astronomers call this feedback. It may sound destructive, but it is also a form of balance. If galaxies formed stars too quickly, they would burn through their fuel and fade prematurely. Black holes regulate the pace, ensuring that galaxies evolve steadily rather than in a single brief flare. In other cases, the energy released by a feeding black hole compresses clouds of gas, triggering starbirth instead of quenching it. Outflows stir turbulence. Jets sculpt regions where new stars spark into existence. A black hole's influence can both limit and ignite. It is not only a destroyer, but also a gardener, cultivating its galaxy with bursts of energy. In their silence, black holes shape the ecosystems of the cosmos. Consider quasars, those brilliant beacons from the early universe, powered by black holes devouring matter at furious rates. They lit up the darkness of young galaxies, sending energy across intergalactic space. Some quasars are so bright we can see them from billions of light years away, their light traveling most of cosmic history before reaching us. They are relics of a time when galaxies grew fast, when black holes fed hungrily, when the universe was young and fiery. Quasars remind us that black holes are not always quiet. Sometimes they are among the brightest objects the universe has ever produced. Even when dormant, their presence matters. The stars near Sagittarius AI orbit in tight, fast loops, proving the black hole's gravitational anchor. Without it, the galactic center might be a looser, less organized place. In distant galaxies, removing the black hole from the equation would change how stars cluster, how arms spiral, how gas flows. They are central, not just in location, but in influence. Galaxies and black holes evolve together, partners in a cosmic duet. Astronomers have discovered correlations between the mass of a galaxy's central black hole and the properties of the galaxy itself. The larger the black hole, the more massive the surrounding bulge of stars. This relationship suggests co-evolution, as if galaxy and black hole grow hand in hand. Feed one, and the other expands. Quench one, and the other settles. They are not separate stories, but chapters of the same narrative. It is humbling to realize that the great spirals we admire in the sky, the giant elliptical galaxies in clusters, the delicate dwarfs orbiting larger neighbors, all owe part of their identity to invisible horizons. From within, galaxies are vibrant ecosystems of stars and planets, but beneath it all, shaping quietly, lie black holes, silent architects of cosmic structure. As you rest tonight, imagine that influence extending across time. Imagine stars being born because a black hole's jets compressed their cradle. Imagine galaxies growing steadily because their central horizon prevented chaos. Imagine the Milky Way itself, shaped not only by collisions and mergers, but by the silent presence at its core. You are living in a galaxy balanced by a black hole. Its stillness makes your life possible. And as you close your eyes, you too can feel that balance. Breath and pause, tension and release, growth and rest. The same cycles that govern galaxies govern you. Black holes, stars, planets, people, all moving in rhythms, all part of the same fabric. Tonight you are safe within that fabric, drifting quietly under its patient design. Not all black holes are the same. Some spin. In fact, many of them do. A rotating black hole, known as a Kerr black hole, is stranger than any still horizon. Its spin drags space-time itself around with it, twisting the very fabric of reality into a whirlpool. This effect is called frame dragging. Near such a black hole, space and time no longer simply curve inward. They swirl, pulled along by the black hole's rotation, as though the universe itself were caught in a cosmic current. If you could hover close, you would find that you could not remain still. Even if you resisted with rockets or engines, the spin of the black hole would carry you along. This region, outside the horizon, but still under its spell, is called the ergosphere. Within the ergosphere, nothing can remain motionless. Everything is dragged forward. It is not yet the point of no return, but it is a place where choice narrows, where the spin of the black hole dictates the flow of time and motion. And yet, within this strangeness lies possibility. In theory, the ergosphere allows energy to be extracted from a rotating black hole. This is called the Penrose process. A particle entering the ergosphere can split, with one fragment falling inward and the other escaping outward with more energy than it had before. In this way, the black hole's spin can be tapped, drained, converted into usable energy. The idea sounds like science fiction, but it arises naturally from the mathematics of relativity. Black holes are not only destroyers, they are potential engines, cosmic batteries waiting in the dark. Rotating black holes may also open possibilities for wormholes or other exotic structures. The equations of relativity suggest that rotation stabilizes space-time differently than stillness, perhaps permitting tunnels to form, pathways between distant points. Whether these wormholes could ever exist in reality, or whether they would collapse too quickly, remains unknown. But in the mathematics at least, the idea lingers that rotation itself could open doors in the universe. Spin also changes how black holes interact with their surroundings. The direction of a black hole's spin influences the shape and strength of the jets it launches. It affects how gas spirals inward, how disks glow, how energy escapes. The dance of galaxies and stars is not only a matter of mass, but of rotation. Spin gives black holes character, individuality, hidden fingerprints on the cosmos. Some black holes may spin slowly, barely dragging space at all. Others may spin near the maximum allowed by physics, whirling at the edge of possibility. Imagine such a black hole, its horizon blurred by motion, its ergosphere a vast current sweeping everything along. If you orbited it, time itself would be twisted, your path bent not only by gravity, but by rotation. To move there would be to surf on space-time itself, caught in a tide no ocean could ever match. For us, far away, the details are mathematical, but in your imagination, you can see it. A whirl of stars around a darkness that spins, light bending into spirals, matter glowing as it falls, space-time stretched like fabric, caught in a vortex. It is both terrifying and beautiful, a reminder that even the deepest voids have structure, even silence has motion. As you let go tonight, think of that spin. Think of the universe twisting softly, slowly, carrying galaxies forward. Think of how your own life has its own rotations, days spinning into nights, seasons circling, breaths rising and falling. You too live in cycles. You too move in rhythms. Rest is part of that rhythm. Sleep is part of that spin. Tonight you drift not into stillness, but into gentle motion, turning softly with the cosmos itself. Some black holes are imagined with more than mass and spin. In theory, they could also carry charge. A charged black hole, known as a Reissner-Nordström black hole, would have electric fields as well as gravitational ones. In reality, most black holes are thought to be nearly neutral, because any strong charge would quickly attract opposite charges from surrounding plasma, balancing itself out. But in the language of physics, the equations allow for such creatures, and so they live in our imagination. A charged black hole would have layers of horizons, not just one event horizon, but two, nested like invisible shells. The outer horizon would act as the familiar point of no return, but inside, closer to the center, a second inner horizon would exist, separating regions of space-time like curtains drawn across reality. Between them, strange dynamics could unfold, where energy builds and collapses in an unpredictable way. The mathematics grows chaotic, hinting at instabilities, storms in space-time itself. And beyond charge, theorists consider combinations, a black hole with mass, spin, and charge together. the Kerr-Newman black hole. In the abstract realm of equations, such an object twists spacetime with rotation, pulls with gravity, and hums with electric fields all at once. Whether nature makes such black holes is uncertain, but in possibility they remind us that horizons come in varieties, that not all darkness is the same. There is even a limit, a boundary of possibility. Add too much charge or spin, and the horizons vanish, leaving what physicists call a naked singularity. A point of collapse without an event horizon to hide it. Naked singularities, if they exist, would reveal the raw heart of space-time, exposing the singularity to the universe. Most believe the cosmos forbids this, that some law of cosmic censorship keeps singularities clothed, horizons always intact, but no proof yet confirms it. So we wonder, does the universe allow such exposures, or are black holes always veiled? Even if such charged or naked forms remain theoretical, they push us to think about what black holes mean. Are horizons walls, or skins, or illusions? Do they hide reality, or create it? By studying their variations, physicists test the strength of relativity, probing where the theory holds and where it cracks. Black holes are puzzles, and every variation is a piece of the larger picture. But the beauty lies not only in the math. Imagine standing near a charged black hole. You would feel not only the pull of gravity, but the force of electricity. Particles streaming around it would move in arcs. Caught between two invisible fields, the accretion disk might shimmer differently. Light bending not only through space-time, but through charged plasma. Even without proof that such black holes exist, the picture itself glows in the imagination, a reminder that the cosmos is full of possibilities beyond what we see. Perhaps most black holes are simple, mass and spin, nothing more. Perhaps exotic variations remain hidden in equations alone. But even if so, they have value. They stretch thought. They remind us that reality may not be as narrow as our current evidence shows, that the universe may surprise us still. And as you rest tonight, you too can hold opposites within you. Mass and lightness, motion and stillness, silence and thought. Like the black holes of theory, you are more than one thing. You are not only body, not only mind, but a combination woven together. Sleep does not erase you. It gathers your layers, folds them into one, and carries you into quiet. Rotation does more than twist space-time. It also creates the possibility of taking energy from a black hole. This idea, first proposed by Roger Penrose, is known as the Penrose process. It begins in the ergosphere, the strange region outside the event horizon of a spinning black hole where nothing can stand still. In this region, particles are dragged forward, forced to move with the rotation. But under the right conditions, one particle can split into two. One fragment falls inward, carrying negative energy relative to the universe outside. The other escapes, carrying more energy than the original particle had. In this way, the black hole's spin is tapped, drained. Little by little, energy is extracted from the rotation itself, without ever crossing the horizon. What falls inward reduces the black hole's spin. What escapes carries that stolen energy back into the cosmos. It sounds impossible, like stealing from the void. And yet, it arises naturally from the mathematics of relativity. The Penrose process shows us that even in the silence of horizons, there are loopholes, subtle flows where energy can be borrowed and returned. Black holes are not locked boxes. They are systems, dynamic and interactive, able to give as well as take. In astrophysics, something similar may already be happening. The enormous jets seen shooting from active black holes may in part draw their power from the rotation of the horizon itself. Magnetic fields twist in the ergosphere, channels of plasma spiral outward, and rotational energy is converted into streams that pierce across light years. This is known as the Blandford-Zermzsek process, a cousin to Penrose's idea, Realized on galactic scales, the black hole spins, and the universe reaps the power. If we could ever master such processes, humanity would possess an energy source almost without limit. A single black hole could supply more power than all the stars of a galaxy. Of course, this remains only speculation, but the concept alone is enough to inspire that within the depths of darkness lies the possibility of light, of energy, of motion. That what seems like an ultimate end may, in fact, be a wellspring. The Penrose process also carries metaphor, that even in situations that seem like traps, there may be hidden exits. That even where everything appears to fall inward, there can be flows outward, gains unexpected, gifts unimagined. Black holes remind us that the universe is not simple, not one-directional. It has currents and countercurrents, balance and exchange. Imagine drifting in the ergosphere, pulled forward by the black hole's spin. You cannot resist the motion, but you can use it. Like a boat caught in a current, you may steer, you may ride, you may harness the tide. In this way, the ergosphere is not a prison, but a river, and the Penrose process is the oar. Physics is not only about limits, it is about possibilities. And as you lie here tonight, you too may feel the pull of cycles, the spin of days into nights, of thoughts into dreams. You cannot stop the turning, but you can rest within it. You can flow with it. You can find energy in its motion. Sleep itself is a kind of Penrose process. You give your body to the pull of rest, and in return, you wake renewed, carrying more energy than you began with. The universe, it seems, has always known this rhythm. Black holes are not only engines of gravity, they may also be among the most powerful particle accelerators in the universe. Around their horizons, matter moves at extraordinary speeds, swirling in disks, colliding, heating, glowing. Magnetic fields twist and snap, launching particles to near light velocity. Radiation streams outward across the spectrum, from radio waves to gamma rays, where human-made accelerators like the Large Hadron Collider span kilometers. A black hole's natural accelerators span light years. They turn gravity into motion, and motion into energy. At the edge of an accretion disk, particles crash into one another at energies far beyond what our instruments can achieve. These collisions may forge new particles, break apart old ones, and reveal conditions similar to those of the early universe. Some of the highest energy cosmic rays ever detected on Earth, particles striking our atmosphere with energies millions of times greater than anything we can make, may have been born near black holes. We are, in a sense, touched by their distant laboratories. Jets launched from black holes are part of this acceleration. Narrow, focused streams of plasma are hurled outward for thousands, sometimes millions of light years. Within them, particles spiral along magnetic fields, gaining energy with each turn. The jets shine in radio, X-ray, and gamma radiation, broadcasting their presence across space. For galaxies billions of light years away, these jets can be the brightest features we see. They carry signatures of acceleration, whispers of particles riding magnetic storms near horizons. Some black holes may accelerate not only protons and electrons, but heavier nuclei. In doing so, they contribute to the cosmic mix, scattering enriched particles across interstellar and intergalactic space. These particles become part of gas clouds, part of new stars, part of planets. Even here, on Earth, the air we breathe carries atoms once shaped in distant accelerators, perhaps launched long ago from the jets of black holes. Their story is woven into ours, even if we never feel it directly. In theory, rotating black holes could accelerate particles through processes like frame dragging. Imagine a charged particle spiraling around the ergosphere, gaining momentum from space-time itself, slingshotted outward at energies unimaginable. Nature has already built machines more powerful than anything humanity may ever create. The challenge is not to construct them, but to interpret their signals, to read their outputs across the dark. But there is beauty in thinking of these accelerators, not only as violent, but as creative. Out of chaos comes structure. Out of collisions comes information. Out of motion comes light. Black holes, in their quiet way, remind us that energy and knowledge often arise from tension, from friction, from edges where forces push hardest. They are not only places where things end, they are also places where new physics begin. As you let yourself drift deeper tonight, imagine the quiet hum of particles spiraling, gaining speed, rising outward like sparks. Imagine the night sky glowing not only with stars, but with hidden beams from galaxies far away, beams born near horizons, carrying energy across cosmic distances. You may never see them with your eyes, but they pass through you all the same, invisible messengers of motion. To rest is not to miss them, but to join them. Your own breath, a rhythm, your own thoughts, particles rising and falling, your own body a quiet accelerator of life. From the edges of black holes, some of the most dramatic structures in the universe are born. Cosmic jets. These narrow beams of plasma, launched at nearly the speed of light, pierce through galaxies and stretch far into intergalactic space. They are slender, focused, and yet immensely powerful, carrying more energy than millions of suns. To see them in radio images is to see the fingerprints of horizons drawn across the sky, straight lines of brilliance where silence should reign. How these jets form is still a mystery. The best theories suggest that magnetic fields twisted by a spinning black hole act like wires, channeling charged particles outward. The disk of matter spiraling inward becomes a dynamo, converting rotation and gravity into kinetic energy. The black hole itself may even lend its spin, drained through processes like Blandford's Najak, fueling the stream. Whatever the exact mechanism, the result is astonishing. A black hole, the very symbol of collapse, flinging matter outward across millions of light years. Jets are not just ornaments. They shape galaxies. When they slam into surrounding gas, they heat it, stir it, scatter it. They can quench star formation by pushing gas away, or trigger new stars by compressing clouds. They leave cavities, bubbles, and arcs in the halos of galaxies, ghostly signatures visible in X-rays and radio waves. The Milky Way itself bears faint scars of past jets, bubbles still glowing faintly above and below the galactic plane. Our own central black hole may once have been more active, sending streams outward, leaving echoes still visible in the sky. In the largest galaxies, jets can sculpt not only their hosts, but also their surroundings. They pour energy into galaxy clusters, enormous families of galaxies bound by gravity. Without this heating, gas in clusters might cool too quickly, forming stars at unsustainable rates. Jets regulate the balance, stirring turbulence across millions of light years, maintaining equilibrium. They are not side effects, but central actors in cosmic ecosystems. From Earth, we have seen jets so large that they dwarf their galaxies. In some cases, they extend farther than the Milky Way itself, luminous threads threading the cosmos. They are beacons, visible across billions of years, telling us where black holes fed and how galaxies grew. They are lighthouses in the dark, not guiding us home, but reminding us of the vastness of space. And yet, for all their power, they are narrow. If you stood within one, you would be destroyed by radiation. Yes, but the vast majority of the universe is untouched. Like a fire hose spraying across the dark, they focus their fury into slender beams, leaving much of space in silence. The universe, even with jets, remains mostly empty, mostly calm. The drama is contained. There is poetry in this, that from darkness come beams, that from collapse comes expansion, that the very objects that consume also give. Black holes remind us that the universe is full of paradoxes, that nothing is only one thing. They are voids, and yet they produce brilliance. They are silence, and yet they create soundless symphonies of energy. They are ends, and yet they shape beginning. So tonight, as you breathe slowly, imagine those jets arcing across the cosmos. Imagine them carrying energy for millions of years, across millions of light years, crossing the gaps between galaxies. You will never see them with your eyes, but you can picture them, narrow beams threading the universe, silent, patient, luminous. And in your imagination, you too are part of that flow, carried not outward, but inward, into the quiet center of rest. The regions nearest to a black hole are among the most extreme environments in the cosmos. Here, matter is stretched, heated, electrified. Magnetic fields twist like ropes pulled to breaking. Plasma churns in storms, hotter than the cores of stars. And space-time itself curves so sharply that light struggles to escape its own path. If the universe were an ocean, these would be its whirlpools, places where current and tide become inseparable, where chaos reveals hidden order. In the accretion disks that swirl around horizons, gas is compressed to extraordinary densities. Collisions between particles transform motion into heat, raising temperatures to millions of degrees. At such extremes, atoms are stripped of their electrons, forming plasma, a soup of charged particles, dancing under the grip of magnetic fields. This plasma does not flow gently. It ripples, buckles, and bursts, like storm clouds lit from within. Every flicker we see in X-rays from black holes is the echo of this plasma's turbulence, a heartbeat of matter on its way to silence. Magnetic fields, invisible to the eye, dominate here. They thread through disks, twisting into arcs, snapping like cosmic lightning when tension grows too great. These fields help shape jets, funneling plasma outward, carrying particles across the void. But they also sculpt the chaos near the horizon, stabilizing some flows, while destabilizing others, carving patterns into what might otherwise be pure disorder. To study black holes is to study magnetism on scales so vast it dwarfs every experiment on Earth. The gravity near a horizon magnifies these forces. In normal space, light travels straight. Particles follow paths we can predict. Near a black hole, those paths bend, loop, stretch. Even time itself is pulled into the current, ticking differently depending on distance. It is not only matter that behaves strangely here. It is reality itself, reshaped by weight and motion. And yet, for all the chaos, there is elegance. Simulations of disks show spirals forming, ordered waves within turbulence, flares rise and fade in rhythms, quasi-periodic oscillations that suggest patterns hidden beneath noise. It is as if the storm itself hums a song, one too low and complex for us to hear directly, but visible in the way light pulses. Black holes, even in their violence, reveal structure. Astronomers peer into these regions with instruments that see not only visible light, but also X-rays, gamma rays, and radio waves. Each wavelength shows a different layer of the storm. Together, they paint a picture, not of silence, but of activity, a cauldron at the edge of collapse, boiling and glowing, feeding and radiating. We cannot see the singularity, but we can see its shadow, outlined by the fury, just outside. For us, safe on Earth, it is easy to forget that such extremes exist. We live in gentle conditions, our skies calm, our gravity light. And yet, even here, plasma dances in auroras, magnetic fields ripple across the sun, storms light the sky. The extremes of black holes are not separate from us. They are the same physics, magnified, pushed to their limits, showing us what reality can do when gravity is strong. As you close your eyes tonight, imagine drifting at the edge of such a storm. You are not afraid. You are not consumed. You are simply watching the currents of plasma swirl, watching magnetic arcs bend and shimmer, making time itself curve into spirals. The storm is not noise, but music. The turbulence is not threat, but rhythm. and in its rhythm, you find calm, a reminder that even chaos has patterns, even extremes have beauty, even horizons have light. Black holes live not only in physics, but in our imagination. Long before they were confirmed by observation, they appeared in thought experiments, in metaphors, in myths of cosmic abysses. To us, they are not just horizons of gravity. They are symbols of fear, of mystery, of silence, of transformation. When we say something is a black hole in our lives, we mean it swallows without return. When we dream of them, we place ourselves at the edge of the unknown. In literature, black holes are often described as gateways or prisons, places where light itself disappears. They echo ancient myths of underworlds, of caves leading to hidden realms, of rivers that flow one way only. In Greek stories, Hades was a place from which none could return. In Hindu cosmology, cycles of destruction and rebirth echo the collapse and renewal. Black holes embody, across cultures, darkness has always been a place of both fear and wisdom, both ending and beginning. Black holes are the modern face of that timeless motif. In art, they inspire both awe and dread. Painters imagine spirals of light feeding into voids. Writers describe them as mouths, as eyes, as bottomless wells. Musicians compose pieces that rise in crescendo and then fall into silence, mirroring the fall into a horizon. Even in popular culture, black holes appear as plot devices, portals to other dimensions, challenges for explorers, metaphors for grief or longing. They are not only objects of science, they are stages for our imagination. And perhaps it is natural, for black holes embody mystery. They are limits of knowledge, places where equations break, where certainty fails. To confront them is to confront the boundaries of our own understanding. No wonder they draw poets and philosophers as well as scientists. No wonder they appear in dreams, in fears, in metaphors. They remind us that not everything is knowable, that mystery has a place in our world. Even in casual speech, we use them. A black hole in a budget, in a schedule, in a heart. Something that takes and does not return. Something that feels infinite in its hunger. The metaphor is imperfect, but powerful. It shows how deeply these cosmic objects resonate with human experience. We see ourselves reflected in them, our struggles, our questions, our silences. And yet, there is beauty in this resonance. To take something so vast, so distant, and weave it into our language, our art, our stories. This is what it means to be human. We look into the night sky and see not only stars, but symbols, not only galaxies, but guides. Black holes are real. Yes, but they are also mirrors, reflecting our inner lives back at us through the lens of cosmic mystery. As you lie here tonight, think of that the same object a physicist studies with equations is the one a poet describes with words, the one an artist paints, the one a child imagines as a portal to another world. Black holes belong to science, but they also belong to story. They are not only out there, but in here, in our minds, in our dreams, in our language. And so, as you drift towards sleep, you too step into that shared imagination. You are both scientist and poet tonight, both observer and dreamer. The horizon you approach is not a threat, but a metaphor. Not an end, but an image. Sleep itself is a kind of black hole, pulling thought inward, erasing noise, leaving silence. And just as in the cosmos, silence is not absence, it is depth, it is rest. The story of black holes is not finished. We are only at the beginning of learning how to see them, how to hear them, how to understand them. For centuries, they were only equations, silent predictions in the mathematics of Einstein and others. Now they are images, ripples, data points, and the future promises more. Humanity is building instruments that will let us peer closer, listen longer, and perhaps even map horizons in detail. The night ahead is full of discovery. The Event Horizon Telescope gave us our first glimpse. The blurry rings of M87 and Sagittarius A, shadows outlined in fire. In the years to come, upgrades will sharpen those images, turning blurred halos into clear portraits. We may one day see the motion of accretion disks frame by frame, movies of matter circling the brink, flaring and vanishing. Time-lapse horizons, alive before our eyes. Space-based gravitational wave observatories, like the planned LISA mission, will listen to lower frequency waves than Earth-based detectors can hear. They will catch the slow spirals of supermassive black holes merging in distant galaxies, events that sing for months instead of seconds. Through them we will hear the deep notes of the cosmic symphony, bass tones too long for LIGO to detect. The universe is already playing the music. We are just learning to listen. X-ray telescopes will map flares in more detail. Radio observatories will trace jets across millions of light years. Infrared instruments will peer through dust, watching stars circle invisible centers. Each wavelength adds another layer, another perspective, another clue. Piece by piece, the portrait grows sharper. What was once invisible becomes a little clearer, a little more real, and perhaps one day probes may approach closer. Instruments launched into deep space, skimming the outskirts of horizons, measuring how time stretches, how light curves, how space twists. No human could survive such a journey, but our machines could, and through them, we could step closer to the singularity than ever before, gathering not only data, but perspective. Horizons may never be crossed, but they may be touched, their edges mapped with patience and care. Even in theory, progress continues. Physicists work to unify relativity and quantum mechanics, to reconcile the paradox of information, to understand how horizons encode data. Some believe black holes may one day lead us to a theory of quantum gravity, a framework that reveals the fabric of space-time itself. To solve the riddle of black holes is to solve the riddle of the universe, what it is made of, how it began, how it may end. And so, when you think of black holes, think not only of what we know, but of what we will know. We live in a moment between ignorance and clarity, a bridge between wonder and understanding. The next century may bring discoveries as unimaginable to us now as images of horizons would have been to Newton. The journey is far from over. As you rest tonight, imagine those future instruments already working, their antennas open, their mirrors aligned, their detectors humming in the dark. Imagine the data flowing back to Earth, numbers turning into images, signals turning into sound, equations turning into insight. Imagine humanity, patient and curious, reaching farther into the dark. The universe is not silent. It is waiting. And in your sleep, you too are waiting, preparing, resting for your own discoveries. When morning comes, black holes teach us not only about physics, but about perspective. They are boundaries in nature, places where our equations fail, where knowledge itself has an edge. To confront them is to confront limits. And yet, limits are not walls. They are invitations. The horizon is not the end of curiosity. It is the beginning of deeper questions. When we speak of black holes, we speak of silence. They emit no light of their own. They swallow signals, erase path, and yet, in that silence, there is meaning. It is not emptiness, but fullness, not absence, but density. Silence is not void. It is depth. To listen to a black hole is to listen not for noise, but for the spaces between. They remind us that quiet can be as powerful as sound, that mystery can be as valuable as knowledge, that stillness has its own kind of weight. They also remind us of humility. The universe is not built to suit our minds. It stretches beyond what we can imagine. It curves reality in ways we struggle to describe. It lasts longer than any scale we use to measure. And yet here we are, tiny and fragile, building equations, telescopes, metaphors. To study black holes is to admit our smallness, but also to celebrate our vastness, that we can even imagine them at all. We are small in size, but great in curiosity. Philosophers once asked whether we could ever know the thing in itself, reality beyond perception. Black holes are modern versions of that question. We cannot see past the horizon. We cannot touch the singularity. We know only the edges, the shadows, the echoes. But perhaps that is enough. Perhaps the edges tell the story as well as the center. Perhaps the universe whispers its secrets, not in what it reveals directly, but in the way it bends, the way it hides, the way it compels us to wonder. And in the end, black holes remind us of connection. They are not isolated voids. They shape galaxies, sculpt stars, launch jets, stir clusters, ripple space-time. Their influence extends across billions of years and billions of light years. And through those chains, they shape us too. Without them, the galaxies we call home would be different. Without them, the atoms in our bodies might not have formed as they did. They are not far away. They are here, woven into our story. So as you prepare for sleep, think of limits, not as ends, but as horizons. Think of silence not as emptiness, but as rest. Think of smallness not as weakness, but as scale. You are part of a universe that holds black holes, and yet you can imagine them, describe them, turn them into stories. That is no small thing. That is its own kind of light. And when you close your eyes, you step into your own horizon, crossing into dreams where time flows differently, where silence becomes meaning, where darkness is not threat, but comfort. Black holes may sit in the cosmos, but their lessons sit in you. You are not outside their story. You are part of it. And tonight, that story carries you gently into sleep. Black holes are the universe's quietest storytellers. They say nothing. They shine with no light of their own. And yet, through the way they bend space, through the way they guide stars, through the way they whisper paradoxes into physics, they tell us everything. They tell us that time can stretch, that matter can collapse, that light itself can be trapped. They tell us that endings exist, but that endings are not the same as absence. In their silence, they speak of balance, of mystery, of patience. As we drift here, thinking of them, it is easy to imagine the darkness as frightening. But black holes are not enemies. They are simply part of the structure, part of the cycle. Without them, galaxies would not form as they do. Without them, stars would not gather in spirals. Without them, the history of the cosmos and of us would be different. Even the iron in your blood, the calcium in your bones, the oxygen in your lungs has felt their influence. You are not separate from them. You are tuned to them, connected through time and matter, bound by gravity and light. Perhaps that is the greatest lesson, that the universe is not made of isolated parts, but of connections. Black holes may seem like isolated prisons, but even they are woven into the fabric of everything else. Their horizons curve space around them. Their growth shapes galaxies. Their collisions ripple through the entire cosmos. They are nodes in the great web, points of gravity, where the universe folds inward and then extends outward again. And you, lying here, breathing quietly, are part of that same web. The same gravity that shapes horizons holds you to the earth. The same space-time that bends around galaxies cradles your sleep. Think of how small we are, and how vast the cosmos is. And yet, to think of it at all is to be vast ourselves. No star, no horizon, no singularity wonders about existence. Only we do. And in that wondering, we stretch ourselves beyond our size, beyond our lifespan, beyond our corner of space. Black holes are not just out there. They are inside us, in the questions we ask, in the awe we feel. in the way we lean toward mystery. And now, as the night deepens, the story grows quiet. We have wandered across horizons, through singularities, into the distant future of the cosmos. We have traced the paths of stars, listened to the hum of gravitational waves, imagined the universe collapsing and renewing itself. And still the black holes remain, patient and silent, waiting at the edges of light. There is more to learn, more to imagine, more to discover. But for tonight, that is enough. So let the story fade. Let the horizons close softly around your thoughts. The universe will continue. Stars will burn, galaxies will spin, black holes will shape and shift. While you rest, you are safe to sleep. You are safe to drift. You are safe to let go. The atoms in your body are older than the earth. They were forged in stars, carried through space, gathered here. You are part of the same story as black holes, written in the same cosmic ink. And tonight, you return to that story not through collapse, but through rest, through sleep, through quiet. Good night, dreamer of galaxies. May your rest be deep, your dreams soft, your thoughts carried gently on the same fabric that holds the stars. The universe is vast, but tonight it is small enough to hold you, and in its arms you are home.